Okay, we can continue from where we ended last time. We're looking at example 2. Okay, here what they're asking is, what is the calculate the y-centroid of the triangle using the triangle area, the area that we are focusing on, using horizontal element shown. So basically, they want us to use this element that they've shown us here. So this element that they've shown us, we'll be moving it up and down like this until it covers the entire area of the triangle that you see there. Okay, so it's the y-centroid that we are interested in.
Sorry, sir.
Can you hear me well?
The screen is not showing yet.
It's not showing.
Yeah, it's not showing.
Okay, let me just share it again. Can you see it now?
Still nothing.
Okay, let me stop sharing. Okay, now?
It's just saying you're sharing a screen, but it's not showing anything.
Okay. Okay, so this is an example where
Yeah,
we
yeah,
started.
it's showing, sir.
Okay. Okay, so all they're asking here is to calculate the y-centroid for the triangular area by using the horizontal element that they've shown here. Okay. So again, just like for the other examples, you are given the shape here. So basically, you're gonna have to make use of the equation again for y-centroid. Let me just draw it here. Okay, you can see the shape how it is. Okay. The triangle like that. Okay. So basically, they want us to find this the y-centroid. So you again start with your equation. Y bar is equal to the integral. Integral
Sir,
for y. Can you see?
no, the sound is funny. I don't know.
Is it? Let me just put the laptop closer. Even now. Are you there? Are you there? Brooklyn, can you hear me?
Can I?
Is the sound still funny?
Sound is breaking.
Something with the network. Right?
So clearly.
It's still not clear, eh?
Yeah, the sound is up, but I can. Yeah, I can see.
Okay. You can see the equation that I've put here, eh?
So.
Okay. So it's the same equation again. You're gonna have to divide it by the area that is given. If you look at the shape that you're given, it was like it looked like this is your y-axis. You can hear me, eh?
Yes, sir.
Okay, and this is your x-axis, and the triangle looked like that. Okay, so this is the small strip that was here that they were talking about that they want us to use. Okay, so from based on this, you can already see that this is a. Let me just label some of this. Okay, so from here to there, this is your dy, and this area down here it's your y. Okay, so from here to here, they call it v. Okay, so now This is the height here at the top here. So for in this equation, for you to find the y centroid, okay, this is the basic equation that you need. So you just need to find the area, and also you need to integrate to find this. Okay, because this is a regular shape, the area you can actually calculate it straight from the area of a triangle formula. Area is equal to half breadth times height. Okay, that one is fine. So this is a regular shape. That's the advantage. Okay, then for the rest of the numerator, you're gonna have to integrate. Can you hear me? Okay. Now we have to solve the upper part, that numerator part. Okay. It's equal to. So now with this one, what's gonna happen is now, okay, you put up your integral sign. It's as usual. Why? So this the area of this small portion now, this small piece here, it will be your dA. That dA, because it's this small piece that you see here. The small piece is just having a. If you look at it well, that small piece is like that. Okay, this portion, this side, this is your dy, and from the breadth here to here, like that. It's that would be now, that would be now in terms of x. I think they should have given x somewhere here. Yeah, it should be x because it's on the x-axis parallel to the x-axis. So this should be x down here. So basically, you need to find now the area of this shape. So dA is equal to x dy. So this portion is the one that you put here in terms of dA here. So you put x dy there. Okay.
Not dx.
There. You're saying?
Only
This should be dy, isn't it? Because this
yes.
was dA here. Yes. Okay. So now what's gonna happen is we need now to the challenge that we have now is this x here. We need to put x in terms of y so that we can integrate with respect to y. Okay, but for us to do that, we can do it somewhere here. Okay, we can do it. Let me just erase this portion down here. If you look at this triangle, there's a small upper triangle, and then again there's the bigger one, the bigger triangle. This small upper portion, this portion up here, this portion here, and then you have the big one, the entire triangle itself. So you can use some the properties of those two triangles to estimate x, because you are given that the small triangle, the base here is like x, while the base of the big triangle here is b. It's b here. Okay, this is x here at the bottom. Okay. And then here you are given the height. You're given that the height of this big triangle is h. While for the small one, for the small triangle here, it would be, because this y is ending here at the bottom of the small triangle. So the height of the small triangle will just become h minus y, minus y. Okay. So if you have that, then if you can use now those properties now to write an equation in terms of x, to x as a function of y. So you can do it like this now. You have h, you can say h is equal to h over b at the bottom here is equal to h over b is the same as h minus y over x. Therefore, you can say x is equal to, then you make x the subject of the formula in here. Then you're gonna end up with, you take b up here, it's gonna become b times h is h minus 1, divided by h. Okay, so this is x. That the x that you found there is the one that you're gonna have to substitute now in this equation. Are you with me up to there?
Yes.
Okay. Okay, then you have y here times now that equation b h minus y is b over h dy. Okay, so we need to integrate this. Okay, for us to integrate this, we can remove b. We can take b over h out. You're left with y h minus y dy. Okay, then once we have those, we can just multiply in within also. Then you're gonna have yh here minus y squared. You put this one inside, then you put back the integral sign b over h. Then again you put a bracket here d dy. Okay, once you have that, what you're gonna do, yeah, you can then just integrate the equation. Then you're gonna have your b here over h. Okay, you have y here, so this one will become 1 over 2. It will basically become like a, okay, remember now this we're gonna have to integrate this from because of the height of the triangle, because we are integrating the part that we are integrating, that we are using for this integral that we are moving, is this horizontal one. So this horizontal element, we're going to have to move from the top of the triangle to the bottom. So it's moving alongside the height from 0 to h at the top here. So you're going to have to integrate from 0 to h. Therefore, okay, now if you integrate now, this y will become 1 over 2. Okay, so at the top, you're going to have h y squared over 2. We can put a bracket here. Then you do this from h to 0 like that. Minus, again, this will become 1 over 3. So it's become y to the power 3 over 3 like that, from h to 0. Okay. Okay, once you, okay, then you substitute now. You put in this h, you put it in, then you're gonna end up with like something like b over h here. Okay, this portion here will become h cubed, isn't it? Yeah, this will become h cubed, isn't it? Are you following?
I'm not doing that now.
You're with me, ne?
I'm not.
I can't hear you well.
How did you get the H?
Where did you get? H.
The H3.
Oh, H3. Okay, I substituted the. Okay, here you have hy squared. But remember now, when you are doing this integration, we're gonna have to put this h. We're gonna have to substitute it in back. So this portion will become this portion here, because it's like hy squared. Okay, over 2. Then we put up h, we substitute in h, then this should give us h times h squared over 2, isn't it? You get it there? Then this will become h to the power 3, isn't it? Divided by 2. You get it, ne?
Okay, now I get it.
Oh, okay. Okay. Once you have that portion, the same thing again, you substitute that h back in here. You're gonna get h to the power 3 again over 3. Okay. Then once you have that, okay, then you can say, let's say you can do this over 6. 2 goes in 6 3 times. 3 times h times 3h cubed minus 3 goes in 6 2 times h to the power 3. Okay, then you still have the bh at the outside here. Okay, once you subtract those, you're gonna get bh of b over h. Okay, here you're gonna get this portion now will just become h to the power 3 over 6. H to the power 3 over 6. And then you can actually, this h here can cancel off with the b here, then you will only be having 2 here. And then, which means now your answer should be bh b times h squared over 6. Okay. Okay, you get it, ne? Up to there.
Yes, sir.
Okay. So now, the things that we were looking for is this portion here, the numerator is the one that you have calculated here. This is your answer here. And this new denominator is this here. Okay, so we can basically just substitute in those equations. Okay, let me just make it a bit quick. Okay, so it's gonna become bh squared at the top there over 6 divided by the area. It's this one. You can say it's bh over 2. Okay, so it will become bh squared over 6 times 2 over bh. Okay, this b can cancel with b, h can cancel with this 2, then you're only left with 2. Okay, the 2 can go here once, it can go here 3 times. Okay, so at the end of the day, you're gonna be left with h over 3. H over 3. That's your centroid. It's like a third of the height of the triangle. Just to check if it makes sense, because this is now the height of this triangle. Okay, so let's say the third of it is somewhere, let's say somewhere around here, maybe almost somewhere here. This is almost, it's like what they're saying is this is the centroid is somewhere down here. It's almost like this one is almost 2/3, but maybe a bit down, but somewhere here. You can see it's almost making sense. Let's see what they got there. You see, they got also h over 3. The same process. Okay, you see here they call them similar triangles here. Okay, they're just comparing this portion of the triangle, the small triangle, and the big triangle, just to represent x in terms of y. Okay, are you good with this example?
Yes, sir.
Okay, we can move on. Okay, which one is the next one? Is this one about the centroid circular sector? Okay, you can quickly do this one. Let me just erase this. Okay. Okay, with this one, what they're saying is calculate the position of the x centroid. of the area of the circular sector shown. Okay, this circular sector which is shown. So they want the centroid of the area. So we are making use of a formula for the area, not necessarily the length. Okay, so okay, we have the shape. It looks like this. Okay, so it means basically the y should be 0 here by inspection, because if you look at it here, you can assume this is the center of gravity now. Okay, it's most likely that it will lie in the center here, but this is along the x-axis. If it's along the x-axis, then it means your y component should be 0. So if your y component is 0, so the question that you need to answer now is along the x-axis, where is it now the center line? So that's what we need to find out now. You can see they've cut out a small portion here, okay, small arc. So it's most likely that we might find ourselves using the arc here. Okay, you can see that this is a small triangle that they've put up here. Okay, and the point that and yeah. Okay, let's see how we got this. Okay, it looked like something like having something like that, like that. X here. So the shape was going like that. Okay, the small piece that you took that you are integrating with respect to is this one. So this small piece here, you have a small area here. Okay, so it looks like a triangle if you can see. So this is your angle, your center angle. Okay. So now, okay, on this line now, what you have, this is your radius. You have a radius here, and then along the x-axis, you must have something parallel to it here. I think what did they use it here? 2r cos. Okay, let me just put that on there. 2r cos theta divided by 3. Okay, on this side. Okay, so basically, again, it's the same thing again, because all they want you to find is the x centroid. So you can actually put up your equation here. X bar is equal to, again, the same thing, integral of xe dA area divided by the, because this is like it's not a regular shape, so you can actually just integrate that portion to get that area at the bottom. Okay, so this is the equation. So we need to find both the numerator and the denominator. This is xc. So now we can try to find now, let's say the area of this shape. Again, it will not. We can actually start with it again with the, remember the formula that we used for previously, the one for arc. Okay, so the area, you can look at it like it's like a small triangle which is there. So okay, you can say dA is equal to, let's say, let's see here. How can we do this? You can say the area is equal to, remember the center, and equal to the central angle. I'm not sure if you can see this. Yeah, this handwriting. Central angle divided by 360 degrees times, now that's circumference now, pi r squared. Oh, that's no, I mean, in this case it will not be circumference, just the area, because you are working in area and not the circumference or the length of the arc like last time. So you can say 2 pi, because if you look at that shape, the angles that they put here is 2 alpha and 2 alpha. I mean alpha and alpha here, you can add them up, then it becomes 2 alpha. It becomes 2 alpha here, because that will be your angle at the center. 2 alpha over 360. 360 is 2 pi. It's 2 pi times pi r squared. Okay, 2 pi can cancel with 2 pi. 2 can cancel with, I mean, pi can cancel with pi. 2 can cancel with 2. Then you are left with just alpha times r squared. Okay, so that portion, alpha times r squared, this can be now your, you can say now this is your, the denominator. You can say dA, that integral is equal to alpha r squared. You can say that's the that bottom portion. Okay, you understand me? This one already. Do you understand it? Ne? I can remove it. Okay, so now, okay, so the denominator, we found it already. So now we need to find the numerator. Okay, for the numerator, it's like 3, okay, is equal to, okay, you integrate your x bar now. In this case, your x, I mean your xc, so the center is this line which is horizontal to the x-axis. So it's 2r cos, 2r cos theta divided by 2. I mean divided by 3. That portion times this dA part. Okay, that dA part. That dA part is this portion of this small triangle that you have here. This small portion that you have here. It's not clear. Okay, it looks like this small piece. Okay, it's having an angle here like that. Okay, it's a small angle. Okay, so this end part, this is the, it's having a, okay, and the length here is the radius of the circle that you have here. Okay, that distance is the same, but now you can actually find this portion here. Again, you can actually do it like the way we calculated this. You can say arc length. You can say arc length. Arc length. You can say arc length is equal to center angle, again the center angle, which is this d phi. Okay, you can put it here. It's the same. You are using the same formula again. Divided by 360. That 360 now it will be 2 pi again times 2 pi r square, which is like the circumference now. Instead of using the area when compared to when we are doing the area. You remember when you use that formula? You can still remember, right?
Yeah.
Okay, because this portion here, it was the area, but now in this case, it will be like the circumference of the circle. Okay, 2 pi r, or 2 pi times diameter. Okay, so this now, you can, so this portion here, this 2 pi can cancel with this 2 pi, then you're left with r d pi. So this portion r d phi is the one that you can put in here now. Comes r like that. It's this GA part of it's the area of this small portion of the triangle. No, not like that. Is it real? No. I mean, this portion here, arc length, is just this portion here. It's just coming here, R, like that. It's just this portion, not necessarily the one coming this side. So now what you need to do now is, okay, so now we know this part. So what you need to do now is you need to find the area of this triangle. The area of this triangle, it's like a, yeah, it's like just a usual triangle now, because now you have the height, okay? But remember, this it's not a straight, it's not a right angle, no? It's not at a right angle clearly. It's because there's a curve here, there's an arc here. That's why
Yes, sir.
we have to use this formula to get this height, which is like a which is curved, which is an arc. So the area now, this portion, that dA, because we are using something like a triangle, should be it's just that usual triangle formula. Okay, so you use 1/2. The base now will be r. The base will be r times the height, which is now rd, like with that angle times that angle. So we're gonna have 1/2 r squared and that times d by that angle. So this is what we can use now, this portion now, for representing dA, the small area. So what you're gonna have 1/2 here, r squared d phi, like that. Okay, you understand it up to there?
Yes, sir.
Okay, okay, I'm gonna remove this name. Okay, but it's fine. We can just continue. Okay, we have this already like this. Okay, then we can just maybe manipulate it here quickly. This one can cancel with this one. Then, okay, then we're gonna end up with something like so we can just put everything on the side so that we can integrate with respect to that angle. So everything else we can take it outside. So r, we can say r should be r cubed over r cubed over 3, and this integral sign here, cos that angle, cos that angle d that angle. Okay, again, when you are integrating here, okay, but it's when we are integrating here, we are integrating with respect to, because this portion here will be moving alongside from this, from it will be moving around until it covers the entire area. So it will start from this line to this line. So because here they have given that the angle is alpha here, we can say this is like plus alpha, and on this side is minus alpha. So we can use that in our integral. This is like minus, from minus alpha to plus alpha, like that. Then we integrate that. Let me just remove this. Okay, then we integrate. Okay, so integrate, this will become 3 over 3. Okay, this will become, if you integrate, it will become sin angle. Okay, then you put this one here from this guy to that. Okay, it's like that. Then become r cubed over 3. Okay, this sin comes, so that angle minus sin that same angle again. Okay? Okay, because of the signs, you're gonna end up adding them. This will end up becoming plus, so it will end up becoming 2 sin, isn't it?
Yes, sir.
Okay, so at the end of the day, this will end up becoming 2 r cubed over 3. The 2 is coming from the sin here, sin at angle, like that. Okay, so it means now this portion in the numerator, we have it also now, like that. So we can actually substitute both the numerator and the denominator back into this equation, and then we can solve that one. Okay, let me just do it on this side quickly. I'll just erase this quickly. Okay, so I'm just gonna put this equation here quickly. dA over integral. Okay, so the numerator is this one that we have here already. Let me just say 2 r to the power 3 sin at angle divided by 3. Then the whole thing you divide it with the the dA, the area, alpha r squared. Okay, so that's over 1. Okay, end of the day, it's end up becoming 2r cubed sin that angle over 3 times 1 over that angle. That. Okay, and then yeah, then you can manipulate this. So r square can cancel with these two here. With yeah, then you only be left with r up here, and then yeah, that's all. Then at the top here, you'll be left with 2r sin that angle over 3 alpha. So this should be your answer now, your centroid. So this should be your centroid. Let's see what they got. Okay, they got 2r sin angle over 3 alpha. Okay, let's see what they got here. See what this one. Yeah, you see? Yeah, so it's the same. Okay, except the angle here. Okay, okay. You see here, I made a mistake here. It's the same, except the angle when I substituted here, I'm supposed to have this is supposed to be alpha. This should have become alpha after the integration, after you substitute this in. You understand me?
Yes.
Yes, so this should become alpha. This should become alpha. Okay, throughout. This should become alpha like that. Yeah, I think. Other than that, it's exactly the same answer as the one they got. Okay. 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 Do you want us to look at another example, or you are good to go?
I think I'm good to go. When is class again?
Oh, okay. So it's fine, eh?
Yeah.
Oh, okay. Yeah, but all of them are just in the same line. As long as you understand the concept, you should be good to go, I think. Yes. Okay, then I'll share this the link on the same YouTube link, YouTube channel. Then you can always have access to it. Okay.
I also watching the game tonight.
You also what?
Also watching the game.
Oh, Liverpool. Or which game? Oh,
Liverpool.
oh, yeah. I'll go check that one out. I'll check highlights maybe and see.
What team does they support?
Oh, I'm still. I don't really. I really don't have a team yet. Like I support a number of players, but not a team, a separate team. It becomes very tricky.
Very tricky.
Yeah. Okay, then I think you are good to go then.
Okay. Okay.
Okay. Okay, it's cool then. Good night then.
Okay. Good.
Yeah.